Hello everyone, my name is Rachel Anderson and I want to share with you some general topics in the field of biogeography and ecology. Specifically, I will be discussing the broad application of biogeography and how we understand species distributions on multiple scales. This lesson is intended for middle school and high school level students or those of the general public who are interested in ecological topics. I hope by the end of this lesson you will understand how species vary across geographic space at global, regional, and local scales, some of the factors that impact species distribution across these scales, how populations are often patchy due to limiting factors, and some techniques that are used to estimate species abundance and distribution. Biogeography is the study of variation in species composition among geographic locations. There are observable patterns in species composition and diversity across the Earth, and one of the main questions ecologists try to investigate is why some species are found in some areas, but not others. The father of biogeography, Alfred Russel Wallace, pondered the separation of the Pangea and how the Earth's land masses have changed over geological time due to continental drift. Based on the position of the tectonic plates, Wallace described 6 biogeographic regions that have separated terrestrial biota. These geographic regions vary in species composition and diversity due to evolutionary isolation. Wallace further found a relationship between species diversity and latitude. Species diversity is greatest in the tropic region and decreases towards the Earth's poles. There are many hypotheses for this, but some of the most popular include the fact that the tropics have maintained a thermally stable climate over geological time. The tropics are also high in productivity, and it is a large area of land. But the reason for high diversity in the tropics is still uncertain. Species composition and diversity vary across different scales. If we start to zoom in on a species' regional or local distribution, we will start to see different patterns. Populations often have patchy distributions, as we can see in this example of a range map for the greater sage grouse. Species are often not evenly present across a landscape due to a number of factors such as habitat suitability, competition, or dispersal capability. Across various scales, the greater sage grouse population is patchy due to their selection for suitable habitat conditions that meet their life history and ecological requirements. Abiotic factors such as topography or soil nutrients, and biotic factors such as prey availability might affect species across their range. Populations as such are dynamic and change across time and space. In order to better understand wildlife populations across the landscape, ecologists employ various techniques to determine abundance and distribution across both broad and fine scales. Some of these techniques include area-based counts, distance estimation or sampling, mark recapture studies, or remote sensing with technology such as LiDAR. Reviewing this lesson, we learned that species vary across geographic space at global, regional, and local scales, and that there are many factors that impact these distributions. We know that populations are often patchy due to a number of factors, and there are several different techniques you can use to estimate species abundance and distributions. Thank you for listening.